All right, so I ran out of my hour, but that's okay. I only did a little bit more. So um, the next part we have to do is we have to find when f prime of x is equal to 0 or if it's undefined. So it'd be a little bit easier not to use the quotient rule and rewrite this as 1 minus x squared to the negative 1/2. And then I could use the chain rule. So I know the derivative of this would mean the 1/2 has to come out front, and then this has to drop by 1. So the negative 1/2 has to come out front, and that power has to drop by 1. Do not touch the inside. Then you multiply by the derivative of the inside. So the derivative of this inside part is going to be minus 2x. Now, cleaning this expression up, what we're looking for is, what goes on top, what goes on bottom. Well, 2x has a power of 1, so it goes on top. 1 over 2 means that there's a 1 on top and a 2 on bottom, but it's negative. So I just put this negative with this 1/2, okay? So that's why this 2 is on bottom, because I have a 1/2. And I know this 1 minus x squared is going to be on bottom with a positive power because it's a negative 3/2. So when I clean this up, I can take away the negatives because they would cancel the 1. And I can also cancel the 2. So what I'll have is I'll have x all over 1 minus x squared to the 3/2 power. So I want to know when this is equal to 0 or when this is undefined. Okay, so we kind of go back to our algebra skills and look when the thing when a fraction is equal to 0. Well, solving this for 0, I just multiply the denominator over to the side, and what would happen is the entire denominator would go away. So for this part, when this part is equal to 0, so I can separate it here. This is just when x is equal to 0. So that's already solved. Now, when is this thing undefined? Well, it's undefined when the denominator is equal to 0. So this would be undefined when 1 minus x squared to the 3/2 is equal to 0, because undefined means I'd be divided by 0, so that means it'd be undefined. So anything divided by 0 is undefined. So what you can do is you could 3/2 root both sides, but another way you can think about it is the only way you can get something to a power equal to 0 is if what's underneath my finger is also 0. So that means this is when 1 minus x squared is equal to 0. So then 1 is equal to x squared, so x would be equal to plus or minus 1, because it would be the square root of 1. We already solved it up here, this exact same expression. No, similar, I should say. Okay, so that means these are the candidates for its local maximum, local mins. 2, it doesn't have endpoints. It doesn't have endpoints because it's on an open interval. So I'm not sure if it's going to have local maxes or local minimums. So we're going to have to the only possible extreme value is going to be at 0, so we'll have to see what it looks like from there. So there are no endpoints because it's open over here, because it goes from -1 to 1. So that was our domain. So 3, the only candidate I can do is just plug in 0. So what is f of 0? So this is our only extreme value. So when I plug in 0, remember, to the original function, so this would be 1 over the square root of 1 minus 0 squared. So this is just going to be equal to 1. Question, is it a local max or a local min? So one way you can tell if it's a local max or a local min is to kind of look at all the other x values behind it. I know that this is the extreme value, so it's either a local max or a local min, right? It's got to be one or the other. So what I can do is I can pick any other number in here, and I know this is going to be its critical value, right? Well, actually, I don't know that either. To be honest, I technically don't know that because it could look like a saddle. So that saddle point I kind of showed you. So I have to pick a number a little bit above it, a little bit below it. I have to see if they're both below it, okay? So I know that this either is going to crest or trough there. So let's just check. So what I'm going to do is I'm going to plug in a number that's a little smaller than 0 and a little bigger than 0, and then see what we get. So go to my calculator and cheat it a little bit. So let's do this. Y equals 1 divided by the square root of 1 minus x squared. And I'm going to go to my table. So I'm going to go to table set first. I'm going to hit window. And I just want to make sure that this is on ask. So when I go to my table, I can just plug in the numbers that I want. So I have a bunch of numbers from my previous example in pre-calc. So the numbers I want is I want to just pick a number that's a little bit smaller. So how about like negative 0.5 and then 0.5. So what we see is we actually get the exact same thing. This graph actually is an even function if you were to test it out. So that means that these values are bigger than 1. So if you notice that the original value, like this is my extreme value, which gives us an output of 1, and these give you values that are bigger than 1 on both sides of it. So it really has to probably look somewhat, not really parabolic, but you know, it's going to have some kind of a trough at this particular value. So this is an absolute min of 1 at x equals 0. So at 0, 1, it has no absolute max. And that's it. Yeah, I almost made it in an hour, so that's it.